Question number 12. We need to consider the net of a cylinder to find the expression for the shortest distance from P to Q. Now the net of a cylinder, if I was to unroll the centre of the cylinder, I would find that that produces a rectangle, and P to Q, and the distance between P to Q would be the diagonal of that rectangle. I need to find then the length of that line, so I'm going to need to use Pythagoras' theorem. That means I need to know the height and width of this rectangle. The height is straightforward, as it is just the same as the height of the actual cylinder, so that is h in this case. When I unroll a cylinder, I find that the width of this rectangle is the same as the circumference of the circle on the base. Now they're telling me that the radius of this circle is r, so to find the circumference I can either use pi times diameter or the formula 2 pi r. In this case the answer has to be in terms of pi h and r, so I can't use pi times diameter, so I need to say that it is 2 pi r. Applying Pythagoras' theorem then, I find that pq squared is equal to h squared plus 2 pi r all squared. Now the question has asked for p to q, not pq squared, so I need to square root the other side, so I can just simply write that as the square root of the whole expression, and I have my final answer. Given that x is a whole number, explain why 2x plus 1 is an odd number. So when I times any whole number by 2, I get an even number. So 2x is always even, no matter what number I start with. So then I can then say, when adding 1 to an even number, I will always get it equal to be an odd number. Write down an expression for the next odd number after 2x plus 1. So if I did 2x plus 1, if I add one more number onto that, so if I add 1 to that, it becomes an even number again, add another 1, it becomes an odd number, so it will be 2x plus 3. Explain why you think this decision was made and whether you think it is a sensible idea. So they are grouping these two together and they are grouping these two together. Now you can say whether that you agree or disagree with this. So if you agree that this is a good idea, you have to give a reason why, something along the lines of that in both cases there are small frequencies in comparison to the rest of the data. So if you agree, you have to make a statement about the small frequencies, or if you disagree, you have to give a reason why you think it is a bad idea, and in that case you could say something along the lines of you are negating certain pieces of data, you are losing data because you are no longer saying there are 4 between 0 and 10, you are merely saying there are 6 between 0 and 20, so it is a case of lost data. Both answers are acceptable as long as your reason justifies what you've decided. Complete the table below and draw a histogram. So between 0 and 20 there were 6, between 20 and 30 it is simply 10, 30 to 40 is 20, 40 to 50 is 24, 50 to 60 is still 24 again, and 60 to 80 is the last two, which are worth 2 between them. To find frequency densities, we do the frequency divided by the width of the group. So in this case that is 20, so we get 6 divided by 20, which is 0.3. 10 divided by 10 will be 1, 20 divided by 10 will be 2, 24 divided by 10, 2.4, 24 divided by 10, 2.4 again, and then 2 divided by 20 is 0.1. So when you come to draw your histogram, you need to make sure you have an accurate axis where you have across the bottom 0 all the way up to 80, and up the side you need to go from 0 to 2.4. So across the bottom we can have 0, 10, 20, 30, 40, 50, 60, 70, 80, that fits okay. So 10, 20, 30, 40, 50, 60, 70, 80, and at the side we need to go to 2.4. So if we consider 0.2, 0.4, 0.6, 0.8, 1, 1.2, nope, that's no good. So if we say 0.3, 6, 9, 1.2, 1.5, 1.8, 2.1, 2.4, that will be fine. So we're going to go up in 0.3s. It doesn't matter what you go up in on your scale, but you do need to be accurate with your drawings and the correct bar chart then, or histogram drawn reflective of your scale. So from the table we have that between 0 and 20 the frequency density is 0.3. So 0 to 20 there's a frequency density of 0.3. From 20 to 30 there is a frequency density of 1. From 30 to 40 there's a frequency density of 2. Make sure you draw all lines with a ruler. From 40 to 50 there is a frequency density of 2.4. From 50 to 60 we have the same frequency density of 2.4 again, and then from 60 to 80 we drop right down to a frequency density of 0.1. Write down an estimate for the median length of the worms. So in total we have 6 plus 10 plus 20 plus 24 plus another 24 plus 2. We have 86 worms. That tells me that worm number 43 is the middle worm. So I need to look at the 43rd worm. So the first 6 are in this group, 16 up to here, 36 up to here. So the 43rd worm is in the group 40 to 50. Now I need to try and work out the length of that exact worm. So there were 36 to this point, so the 43rd worm is the 7th worm out of these 24. So it is worm 7 out of 24. There are a width of 10 here, so if I times this by 10, I will find what that group is going up in per worm, and I will also find out where worm number 43 is. So that worm is 2.92 centimetres into this group. So obviously the group starts at 40, so I need to add that 40 on to find that the worm is approximately 42.92 centimetres in length. On to the last question. Calculate the length of arc AB given your answer in terms of pi. So I'm trying to find arc length here. I know that I have 12 centimetres all the way across there, and I know that I have 8 centimetres on the smaller circle. So I have 75 divided by 360 times by pi times by the diameter of that arc here, so that would be 24 centimetres. Now it asks for the answer in terms of pi, so I haven't got to do anything about the pi. I need to work out 74 times 24 divided by 360. So I'm going to do 74 times 24 divided by 360. It is easier to do the times on the top first and then divide afterwards. So 75 times 24 and then divide that by 360, and you find that that is equal to 5. So all of these elements put together are worth 5, so your final answer is 5 pi. Calculate the shaded area. So I need to find the area of the large sector and subtract from it the area of the small sector. Again in terms of pi. So the area of the large sector, 75 divided by 360 times by pi times by 12 squared. Again, I need to work out the numbers outside this and then put pi with it. So 75 times 144 divided by 360. So that gives me 30 pi for the larger sector. The smaller sector, same angle, 75 divided by 360 times pi, this time times 8 squared. So I get 75 divided by 360, and I'm going to times it by 64. 75 divided by 360 times 64, and that comes to 13.3 pi, and then I can do 30 pi subtract 13.3 pi, and I find that I'm left with 16.7 pi as my answer for that shaded area.